Hi, 8th graders. Last week in math class, you learned about parallel and perpendicular lines. You also learned how they relate to no solution or one solution or infinite solution in solving our systems of equations. Today, you guys are going to take this a step further and actually we're going to move away from the graphs a little bit and move more into the algebra behind parallel and perpendicular. So you either printed the notes or got some from your math teacher or you're writing it on your own paper. All of that is great. But get the notes ready, pens, whatever you're using to take notes, and let's learn how to write equations that are parallel or perpendicular to another equation. The title of these notes is Writing Parallel and Perpendicular Equations, because that is precisely what we're going to do. It doesn't say graphing, it says writing them. So what is this? What are we doing here? Well, given an equation, you must create another equation that is either parallel or perpendicular to that line given to you, but it needs to pass through a specific point. So just a couple of reminders. Parallel equations have same slopes. The slopes must be the same. And perpendicular equations have negative reciprocal slopes. Okay, so parallel equations have same slopes, perpendicular equations have negative reciprocal slopes. That's going to be really important for the algebra that we need to do here. So it starts with some examples on the front here. It says writing parallel equations. Parallel. Example 1, write the equation of the line that passes through this point and is parallel to this line. Okay, first thing I want to make sure you understand is that parallel means it's never going to cross this line. It doesn't mean it's going to be the exact same as this line. So parallel, well, we just wrote up here that parallel equations have the same slopes. And perpendicular, didn't mean to write that blurb right there, perpendicular equations have negative reciprocal slopes, but it's all about the slopes. The important thing here is the slope. Okay, so that means really the only part of this original equation that I need is the slope. The rest of it's going to change, because in order to be parallel, the slope only needs to be the same. The y-intercept doesn't need to be the same. If they were both the same, it would just be one of those infinite solutions situations where the two lines are exactly the same, and then why do we even have the system? It's really only one line. Weird scenario. So this is going to have a different y-intercept. We just have to find it. And in fact, you'll see here that that's actually not very difficult. We've totally done that before. If I know the slope, I'm going to start a new equation that says y equals negative 4x, but I'm going to write plus b because I don't know that part. I know what it was in the original equation, but I know that this new equation is not supposed to be the exact same line, it's supposed to be parallel to it. So it has the same slope, but it's going to have a different y-intercept. And how do I find that y-intercept? Well, I use this wonderful helper point that they gave me. I need it to pass through that. So I'm going to plug in 7 for y and negative 2 for x. This is absolutely something we've done before. It's just been a little while, so let's make sure we remember it. 7 equals negative 4 times negative 2 is positive 8. And then, of course, I solve for b. Minus 8 minus 8, b equals negative 1. Careful with those signs there. Which means here is an equation, y equals negative 4x minus 1. This is an equation that passes through that point and is parallel to that equation. And if we wanted, we could actually even use Desmos to check that. You could type this equation in and see it. You could type this equation in and not only see that it's parallel to this one, but then you can find that point and click on it and make sure it really passes through there. Okay. All right, so example 2, another parallel example. Write an equation of the line that passes through this point and is parallel to, oh, they made it trickier. Look what they did here. They gave me standard form of this equation, which means I can't just pull the slope from it because I don't know the slope until I'm in slope-intercept form. So the first thing I'm going to have to do here is solve for y. here I go. Minus x minus x. This is something we've done just in this standard. We know what this is about. Negative 3y equals negative x plus 9. Solving for y. Divide by negative 3. Divide by negative 3. And then we have y equals positive 1/3 x minus 3. Okay, I did all of that just so that I would know what slope I'm supposed to use. I cannot know the slope until I'm in slope-intercept form. So I solved it for y so that I could get the slope. Now I'm ready to go. Y equals 1/3 x plus b. And now I'm ready to take this ordered pair and plug it into this equation. So y equals mx plus b. 1/3 times 3 is 1. So now I go minus 1, and b equals negative 2. Watch those signs really closely. And now I'm ready to write my final equation. Y equals 1/3 x minus 2. This equation is parallel to the one they gave me, but it passes through 3, negative 1, which is why I ended up with a different y-intercept. So for today, you need to be able to write, for this extension on this standard, you need to be able to write equations that are parallel to a given equation but pass through a different point. Also, you need to be able to write perpendicular equations. Remember, perpendicular means not only do they cross, but it's a little bit more specific than that. They cross at a 90-degree angle. So in order to write perpendicular equations, we're not going to use the same slope. We still definitely care about slope. We still definitely need to know the slope, but we need to use a negative reciprocal slope. So right down here. Write the equation of the line that passes through the point 4, 3 and is perpendicular to this line. So here's the slope right here, because it's already in y equals mx plus b. But is that the slope I want to use? That's what I'd do if it said parallel, but it doesn't. It says perpendicular. So I want to use the negative reciprocal. 2 over 1, flip it over and do the opposite sign. That's negative 1/2. That's the slope I need to use to be perpendicular to this equation. So nothing about the equation this time should be the same. Now I'm ready to go. Y equals negative 1/2 x plus b. And then it says y, I'm going to plug something into that. Here's my ordered pair. So this is going to say 3 equals negative 1/2 times 4 plus b. Okay. Then I'm going to have 3 equals negative 2 plus b plus 2 plus 2. B equals 5. And I am ready to finish my equation. Y equals negative 1/2 x plus 5. What I just found is I found an equation. If I were to graph these, and you can open up Desmos and check any of these that you do. If I were to type these into Desmos, y equals 2x minus 4 and y equals negative 1/2 x plus 5, not only would I see perpendicular lines, lines that create a 90-degree angle, but I would also see that this new equation passes right through that ordered pair. So once again, I found an equation that is perpendicular to this given equation and passes through a specific point. Let's try that one more time. Perpendicular equations example 4. Guess what I have to do first? Let me use a different color because I feel like I should have on the last one. This says perpendicular, first of all. It's missing a D, perpendicular. Okay. It needs to pass through this point and be perpendicular to this line. I don't know what slope to use until I solve for y. I don't know what slope to use until I solve for y. 3y equals negative 5x minus 21. Divide by 3, divide everything by 3. And in slope-intercept form, I have y equals negative 5/3 x minus 21/3. Oh, that's 7. Even though that part doesn't matter much to me for this, what matters is that this is the original slope. So is that the slope I use? No, because I want to be perpendicular. Perpendicular. This is 3/5. I need to change the sign and flip it over. So instead of negative 5/3, I'm going to use positive 3/5. All right, now I'm ready to go. y equals 3/5 x plus b. I'm going to plug in this ordered pair and get 1 equals 3/5 times -5 plus b. 1 equals, okay, 3/5 divided, that's -3. Okay, plus b. And now I go plus 3 plus 3, b equals 4. And our final equation that is perpendicular to the original equation and passes through the point -5, 1 is right here. Okay, now you are going to try some. Flip this paper over, or if you printed it and it's a separate paper, that's okay. There's a page 2. So we went through 2 examples of parallel lines, 2 examples of perpendicular lines, and now this page says, you try. Write equations that are either parallel or perpendicular to the given lines and passing through the point. So 1 through 4 are all parallel. You need to be parallel to this line and pass through that point. Sometimes you got to solve for y so that you know what slope you're using. And then the last 4 are perpendicular. Write an equation that is perpendicular to the given line and passes through that point. I want you guys to try all 8 of these, and then you will check your answers with your key, and then you'll do some more practice.